Welcome to Conceptual Cambridge. Today we are going to discuss the area under a curve. So basically for this topic all you need to know is that area is equal to the integration of a function. This is what you need to know. Now we are going to discuss why this is, but you can skip this part as it is not exactly in your syllabus, but you only need to know this. Alright, so let me start with an explanation. So let's see, let me draw a curve. Let's say y is equal to x square. Now to find the area under this curve, you can't find exactly because there is no exact formula for this as there is for triangle, rectangle or squares. So for these types of questions, you have to break them into smaller pieces. So let's say if I were to make this curve, let me just name this curve y is equal to x square into smaller parts of this. I'm going to break this curve into rectangles. So now from this you can see if I calculate the area of rectangles, let me put it out like this. You can see I will get an approximate area for the curve, but there will still be space left as you can see the triangles above the rectangles. So there is still space left. So basically this area we can say is equal to y into x, and you have to add up all the smaller rectangles. So for this process we use integration. Basically let's put an equal spacing, like you can say this is 1 2 3 4 5. So your change in x is equal to 1 over here, and this is your y, let's say. So now let me draw another curve like this, and you can see if I make the dx into a smaller value, my triangles will get smaller and it will be a more approximate calculation. Let's say my rectangles will now get closer since the dx is smaller. Now you can see if I keep on going in the same way, so if I keep on making dx approach a smaller and smaller value, let's say approach 0, my calculation gets more and more approximate. I get nearer to the area under a curve. So for this you can say the change in area is equal to the y at that point multiplied by the d of x. Now you can also change this into the other form, that the change in area with respect to x is equal to y at any point. So basically this means the differentiation of area is equal to a function, or the integration of a function is equal to the area. So this is what we are going to use in the next steps. So before we can move on, you have to understand how we can calculate the area under a curve. So basically let's take a function again, the same function y is equal to x square. So you can say this value till you want to calculate till 5, let's say. So what you basically do is put it like this: area is equal to the integration of the function from the values 0 till 5. So there is the upper limit, this is the upper limit, and below is the lower limit that you can put on integrations, and this is how you find the area bounded by a curve between 2 points. So basically for this we took y is equal to x square. So first of all let's integrate this function, and you have probably seen part 1 of this video which explains the integration. So now let us integrate. This is the integration, and now we must apply the limits. So to apply the limits, There was a plus c also, yes. So now we must apply the limits. So basically this is how we apply the limits. We have to subtract upper limit minus the lower limit. So let's say 5 cube over 3 plus c minus, the c's will always cancel out in these type of questions, so you don't really have to write this when you have a limit defined. So 0 cube over 3 plus c. So you can see that the c's will cancel out and this is going to be negative c. So you get 5 cube over 3 as your final answer. This is going to be your answer. Now I'm going to show you another method using the calculator that you can use to find the area under a curve. So first of all, press the integral sign on your calculator as you can see. Now after you have done that, you will have an interface like this. Now all you have to do is press alpha and write your equation. So in our case it was x squared. Let me write that. Now we have to decide the upper limit and the lower limit. So our upper limit was 5 and our lower limit was 0. And now you just have to press is equal to, as you can see, it's the same answer. You can solve your answers like this, but please only use this method after you have find the answer to confirm if your answer is correct. Then you can go back and check what mistake you have made. Alright, now let's move on. Alright, so here we have another type of situation. You can see I've drawn the graph for x square minus 6x. Let's try to find the area between 0 till 6. You can see the difference between this graph is that it is in the negative y coordinates. Alright, so first let's draw the integral sign. So it is from 0 till 6, and our equation is x square minus 6x. Alright, so now let me x square, so it will be 1 over 3x plus 1x cube minus 6 over 2x square. Alright, and now you just need to input the values into this. So 2 minus 6 over 2 into 6 square. So this should give you approximately 72 minus 108, right? So this comes out to 36 and minus 36. Now this is the upper limit minus the lower limit, which is basically just 0. So you can see our answer comes in negative digits. When your graph is below the y-axis, your answer will be in negative, and when it is above the y-axis, it will always be in positive. Remember this. So now let's move on. Alright, so here we have another type of situation. You can see we have the graph for y is equal to x cube minus 8x square plus 12x. So just by seeing the graph, you can see we have to find two areas. This and this is going to be separate. So first we have to find the area for 0 till 2. Alright, so 0 till 2, and our equation is x cube minus 8x square plus 12x dx. Alright, so it's 1 over 4x 4 minus 8 over 3x cube plus 12 over 2 gives me 6x cube. Now we just need to input it. Plus 6 into 2 square. Let me just put it into my calculator. This is equal to 20 over 3. Now I just need the same integral but from 2 till 6. So I'm just going to use the same form but for 2 till 6. So this is my answer for upper part. Now for the down, 1 over 4 into 6 raised to the power of 4 minus 8 over 3, 6 cube plus 6 into 6 squared. And now we subtract it from the lower limit. 1 over 4 into 2 raised to the power of 4 minus 8 over 3 into 2 cube plus 6 into 2 squared. Let me just plug it into my calculator. I should get a negative value for this, always remember that. So I have 1 minus 128 over 3. Alright, so now that we have the upper value of the graph and the lower value, we just need the total area. So we are just going to add it up. This can be positive now because area should be positive, it can't be negative. So you can just do it like this: 128 over 3 plus 20 over 3. So you should get 148 over 3. This is your total area from 0 till 6. You can't add it directly because the area will subtract and you won't get the accurate value for the areas. Alright. So now let's say Cambridge gives us a question like this where they tell us to find the area between 0 till 4. So let's say they tell us to find the area under this graph, this all area. So how are we going to do this? So first of all, don't panic, and now we just have to apply the same logic over here as before, but instead of that we just have to switch the x and y. So for example, we were doing it like this: y dx. Now what we are going to do is do it like this: x dy. We are multiplying every x value with a small change in y now. So that is the difference between both of them. So now let's apply it. We just have to, as you can see, we just have to integrate x over here basically. So our x is equivalent to 4y minus y square dy. Now this is what we have to integrate, and the values that have been given to us are 0 till 4. So you can see the logic is pretty much same. So let me just integrate that. This should be 4 over 2, which is 2 y square minus this should be minus 1 over 3 y cube. Alright, so now we have the limits from 0 till 4. 2 into 4 square minus 1 over 3 into 4. Let me just put it into my calculator. It's 32 over 3. Alright, so you can see the same logic is being applied. However, if it was in the opposite direction, let's say over here, then it will be negative. So the logic is pretty much same. Alright, so now we have area bounded under a line and a curve, or area under two curves. So basically I've taken an example question from the book and we are going to use this to help us understand what is going on. So the question is, the diagram shows the curve y is equal to minus x square plus 8x minus 5 and the line y is equal to x plus 1 that intersect at the points 1, 2 and 6, 7. Find the area of the shaded region. Alright, so we just have to find the area of the shaded region. For that, let me just make a graph over here. 1 minute. So you can see the line goes like this. Let's say this is 1 and this is 6. So this is going to be the area of the line. This is how much area the line is going to cover. And for the curve, it's something like this. This is how much area the curve is going to cover. So just by seeing this, the graphs of these two, you can determine that to find the area of the shaded region, what you have to do is subtract the area of curve minus area of line. This is how you're going to get your answer. Sorry for the bad handwriting, but that's how you will figure out which area you have to find and how you can find it. So first of all, let us integrate. Let me just write the equation. Y is equal to minus x square plus 8x minus 5. So the integration of this should give me minus 1 over 3x cubed plus 8 over 2, which is 4x square minus 5x. So this is the integration for this, and for the line y is equal to x plus 1. This is just going to be x square over 2 plus x. Alright, remember we don't have to find we don't have to add plus c over here, as there is a limit given for us. So the limits that are going to be applied over here is 1 till 6. So let's find the area for both. So minus 1 over 3 into 6 cube plus 4 into 6 square minus 5 into 6 upper limit minus the lower limit. Lower limit just has 1, so we can just input it like this, plus 4 minus 5. One of the answers is this, and the other answer is going to be x square over 2. So 1 over 2 into 6 square plus 6 minus 1 over 2 into 1 plus 1. Alright, let me just get my calculator. Sorry guys, I forgot to put a minus sign over here behind 1 over 3. Alright, so now that I've put that, my answer is going to come out to be 3. Right, and now for this, it is 45 over 2. Alright, so now that I have the areas for both, we know we have to subtract the area of the curve from the area of the line, as the curve has greater area. So 130 over 3 minus 45 over 2. This is going to give us our answer 125 over 6. Alright, so this is how we are going to solve these type of questions. Alright, so here we have another type of integral called improper integrals. So these are just basically integrals which have infinity as one of their limits. There is nothing different in these type of question. You just have to apply what you already know. So you know that in the question they have given you, show that the improper integral 1 over x squared dx has a finite value and find this value, and they've given you the limit. So y is equal to 1 over x squared. Now we just have to integrate this. So this, first of all, this is going to become x minus 2. So this is what you have to integrate. Now minus 2, so this will be minus 1, so that should give you minus x, and x minus 2 minus 1. Alright, so this is going to become minus 1 over x. So this is the integrated form, and now you just have to apply the limits that they have given you. Alright, so upper limit minus the lower limit, as you already know, minus 1 over infinity minus 1 over 1. So this gives you 1 minus 1 over infinity. Alright, so this might be confusing for some people, but now there is something that we are going to do with infinity. So we have to understand what is going on. 1 over infinity, what value is this going to become? So let's say there is a very big number. For example, let's take 1 over 1000 over here. So this gives me 1 into 10 minus 3. So that's like 0.0001, something like that. And now if I take a value greater than 1000, let's say something like this, so this is going to become more and more smaller. So as you can see, these values, they are going to reach 0. They are reaching a very small number, which is basically equivalent to 0. So what you can say is that 1 over infinity becomes 0. This is what you have to understand. As the denominator is approaching a greater and greater value, your answer is going to become 0. So you can type it out here, 1 minus 0, and this is going to give you 1. So this is the finite value that they are talking about. Let's try another question on this. Okay, so here we go. We have another type of question. The diagram shows part of the curve y is equal to 1 over 1 minus x cubed. Show that as p approaches negative infinity, the shaded area tends to a finite value, and find this value. As you can see, it is just the same type of question, so we don't have to panic. We just have to apply what we already know. But if you come to the curve, you can see that p over here is the lower limit as it is smaller than 0. So our 0 is going to be our upper limit. So we can write it like this, 1 over 1 minus x cube, and p is going to come down and 0 is going to come up. Alright, so now let me just change it into the other form, 1 minus x. I'm going to take it up, so minus 3. Okay, so now we have to integrate. So we already know that 1 over the coefficient of x, so minus 1 into 1 minus x plus, okay, and now the same thing over here. This is going to be n plus 1, which is minus 2. So this should give me 1 over 2 into 1 minus x squared. Alright, so now we just have to apply the limits, which were p and 0. So first we have to apply 0 as it is the greater limit. So 1 over 2, 1 minus 0 is just 1, so 1 square, which is just 1 over 2 minus, and now we are going to use p. Alright, so 1 over 2 into 1 minus p squared. Alright, so now that we have this equation, now what we are going to do is find out what is happening to this part of our equation. So let us discuss that. They have given us that p is going to approach negative infinity, so a greater number which is in negative. So let's say we are going to change our equation like this, 1 over 2 into 1 minus, and now we can just put a negative, very big number, 100,000, 10,000, let's say 10,000 squared. Alright, so now we just have to decide what we are going to get for the answer. Let me put it in. So almost 5 into 10 minus 9, something like this. So as you can see, it is a very small number. You can see this is just approaching 0. Again, you can try this with multiple small numbers and you will see that it is approaching 0. So what you can say is that 1 over 2 minus 0. You have the same answer over here again, so 1 over 2. This is how you're going to solve these types of questions. These are very easy. And I think this is the end of this video. Next, we are going to continue with the volume of revolutions. All right.